So now that we know what the Pythagorean theorem is and that it holds true for all right triangles, we can now use that formula to find the missing side lengths of a triangle. Again, our formula being a squared plus b squared equals c squared, and that is when your triangle is labeled with legs of a and b and the hypotenuse is c. So when you're missing a leg of a triangle, you can use this process over here on the left to find the value of that missing leg. So you would be given one of the legs, the values of one of the legs and then the hypotenuse, and we can write the equation for the Pythagorean theorem, substitute in numbers, square the numbers, subtract, find the square root, and then label our answer to find that missing leg. But sometimes you could be missing the hypotenuse of the triangle. In that case, you would use that equation for the Pythagorean theorem, substitute in the numbers, then square the numbers, but then add and find the square root and label the answer. These are the two processes we can use to find the missing side length. You just have to determine if you're missing a leg or a hypotenuse first, so you know which method or which process to use. So let's look at a couple examples. We have our first example here when we have what is the measure of the missing side length of the triangle, and we'll round to the nearest tenth if necessary. So looking at our triangle, we first have to determine, are we missing a leg or the hypotenuse, the value for that in this triangle? Well, we have our right angle here, and I think the first thing to do is look at the side across from the right angle and label that C. That's your hypotenuse. And as you can see in this example, we know the value of the hypotenuse is 18 inches. So we're not missing the hypotenuse. We then are missing a leg. We have one leg, let's call that A. So we have 9 inches is that leg, but we're missing the leg of B. So we need to use the process to find the missing leg of a triangle. We can start off with the Pythagorean theorem. So here we have, writing the equation, we have a squared plus b squared equals c squared. So now we're going to substitute in the numbers for what we know. Again, we know the value of c is 18, so that's why instead of c squared, we now have 18 squared. And we know the value of a is 9, so instead of a squared, we now have 9 squared. And we still have b squared because that is the missing leg. That's our variable we're now trying to solve for. And again, since I'm missing a leg, I really could have labeled 9 as B and the missing leg could have been A as well. It doesn't really matter. It's just really important that your hypotenuse is that value of C. So now after we substitute in the numbers, we're going to solve this equation for B. We'll square the numbers we know. So 9 squared will turn into 81 and 18 squared will turn into 324. We'll subtract 81 from both sides, giving us that b squared equals 243. And so we'll use the inverse of squaring. So we'll take the square root of 243, and the square root of b squared will give us b. So now we'll estimate, we'll round to the nearest tenth, that the square root of 243 is approximately 15.6. So that missing side length of the triangle, B, is approximately 15.6 inches. Now let's look at another example. And again, the directions are to find the measure of the missing side length of the triangle and round to the nearest tenth if necessary. So looking at our triangle, we have to identify, are we missing a leg or are we missing the hypotenuse? In order to determine that, let's first look at our right angle and find the side across from the right angle. That is C. That's the hypotenuse. And you can see we don't know that side measure. We don't know that side length. So we're missing the hypotenuse. We have our measures of our legs. A is 7 inches and B is 4 inches. So we need to follow the process and steps for finding a missing hypotenuse. We'll start with the Pythagorean theorem. So we have a squared plus b squared equals c squared. So now we are going to substitute in the numbers where we don't know the value of the hypotenuse c, so that will stay c squared. but we can then label the one leg A and the one leg B. It doesn't matter which one is which. So in the equation here, we're labeling A 4 and B 7. So A squared is now 4 squared and B squared is now 7 squared. So now we'll actually square the numbers. We'll say 4 squared is 16 and 7 squared is 49. We'll add those two numbers together. 16 plus 49 is equal to 65. We'll then find the square root of both sides to undo that squaring for c squared. So that c equals the square root of 65. And since we're rounding to the nearest tenth, we want to evaluate or approximate that the square root of 65 is 8.1. So the hypotenuse, the missing side length of the triangle, C, is approximately 8.1 inches. Now, sometimes you'll get an example where you have to find the missing side length of a triangle, but the directions don't outright say that. We can use the Pythagorean theorem to help us solve application problems by finding a missing side length. It's just not as obvious as it was in the last two examples. So you can see here the directions just say how high up does the ladder meet the wall, round to the nearest tenth if necessary. But if you notice from our diagram, the ladder is actually forming a right triangle with the wall. In fact, the ladder is going to be the hypotenuse of the triangle because it's across from the right angle that's being formed with the wall and the ground. We have the wall, the ground, and we have the ladder. Now we know that the ladder is 15 feet. That's that length. So we know the hypotenuse length of the triangle. So we know we can say the ladder is the value of C. Now we also know the ground. So that's one of the legs. So now we're missing the other leg, which is the wall. So if we label A and B, we're missing a leg. So if we can find the length of that leg of the right triangle, then we would know the length of where the ladder is meeting the wall, how high up it is from the ground. So we just have to follow the process of solving for a missing leg of a triangle using that Pythagorean theorem. So we'll start with the Pythagorean theorem, a squared plus b squared equals c squared, where again we know that the hypotenuse is the value of c is 15. So instead of c squared, we'll substitute in the number to be 15 squared. And now our two legs, so now our missing leg actually for the wall we're now calling B, but remember it didn't matter. Before I called it A, now I'm calling it B. It doesn't matter because it's a leg. So now if that's B, it'll say B squared, but A, the other leg we know is 5. So A squared is going to be 5 squared when we substitute in that number. We'll then square the numbers, so 5 squared is 25 and 15 squared is 225. We'll then subtract 25 from both sides and find the square root of both sides, so that b squared equals 200 will turn into b equals the square root of 200. And now because we're rounding to the nearest tenth, we'll approximate that b is equal to 14.1. So that side of the triangle, that leg, is approximately 14.1, meaning that the ladder meets the wall approximately 14.1 feet up in the air. So you can see, again, when you have missing side lengths, whether it's a leg or a hypotenuse, you can always start with the Pythagorean theorem and use that to find your answer.